Hey everybody, today we're going to do our last video for this chapter, and we're going to do two quick AP style questions that are going to go through average value. So let's jump right in here. So our first problem gives us the temperature on New Year's Day in Buffalo, New York is given by our function T of H, where T is the temperature in degrees Fahrenheit and H is the number of hours from midnight. So our domain is going to be between 0 and 24. So for part A, it says the initial temperature at midnight was negative 15 degrees Fahrenheit, and at noon of New Year's Day, it was 5 degrees Fahrenheit. And it's asking us to find A and B. So let's see. What I know from this problem, if the initial temperature was negative 15 degrees, I know that T of 0 is equal to negative 15. And then it's telling me at noon of New Year's Day it was 5. So noon is going to be H is 12. So I know that T of 12 is going to be 5. So now we have to figure out a way to find A and B. So I'm going to go back to my function here and let's do some substituting. So for T of 0, I know that I've got negative A minus B times the cosine of pi times, well, my H is 0, so I'm going to put that there, over 12. So now, if we simplify that, really I've got negative A minus, well, let's see. This is going to give me cosine 0, which is just 1. So I'm going to have negative A minus B, and I know that's equal to negative 15. Now let's look at T of 12. Here we're going to have negative A minus B times the cosine of pi times 12 over 12. So these are going to cancel. Now I have cosine of pi, which is going to be a negative 1. So now I have negative A minus B times a negative 1, or negative A plus B, and we know that's equal to 5. So now I have a pretty straightforward system of equations that I can solve to find A and B. So I'm going to take my two equations, negative 15 equals negative A minus B, and 5 equals negative A plus B, and go ahead and solve. The nice thing is using elimination, those B's are already going to cancel. So I have negative 15 plus 5 is a negative 10. Negative A plus a negative A is negative 2A. And when I solve, I get A equals 5. So now I can substitute into my equation. I'm just going to pick this one. I have negative 15 equals a negative 5 minus B. Adding 5, I'm going to get negative 10 equals a negative B, or B is equal to 10. So now we've got our values for A and B. Okay, for part B, it's asking us to find the average temperature. Well, since the function that we're being given is a function for temperature, my T of H here, all this is asking us to do is to find the average value of T of H. And since for the first 10 hours, it's going to be on the interval from 0 to 10. So average value, we know how to do that. I'm going to jump back down here. So I know the average temperature is going to be 1 over B minus A. Well, my interval is from 0 to 10. So it's going to be 1 over 10 times the integral from 0 to 10 of my temperature function. Now I have values of A and B now, so I'm integrating negative 5 minus 10 times the cosine of pi h over 12. And that's going to be dH. And so now we can just put that into our calculator. So here we go. I have 1 divided by 10 times, I'm going to use math 9, integral from 0 to 10 over negative 5 minus 10 cosine of pi x divided by 12 dx. And we're going to get negative 6.910. And so since that's the average temperature, our units for temperature are given in degrees Fahrenheit, so we're going to make sure to include those there. So for those first 10 hours, the average temperature is negative 6.91 degrees Fahrenheit. Now, we're going to skip part C. I don't think it's actually all that meaningful, so we'll skip it for right now. And we'll look at part D. So for part D, it says find an expression for the rate that the temperature is changing with respect to H. Right? If I want the rate that the temperature is changing, I know I'm just looking for the derivative. So I just need to find the derivative of my temperature formula. So I know that T of H is negative 5 minus 10 times the cosine of pi H over 12. So we're going to go ahead and find T prime of H. Okay. So first things first, I know my negative 5, that derivative is going to be a 0, so I'm not going to worry about that. Now, I'm going to do my outside term here. So I have negative 10 times the cosine of something. Well, I know that derivative of cosine is a negative sign. So I'm going to have negative 10 times negative sine. Now, for right now, my insides are going to stay the same, times pi H over 12. And then I have to use chain rule. I have to take the derivative of the inside. Well, the derivative of pi H over 12 is just going to give me pi over 12. So now with some simplification, my negative times my negative is a positive. I know 10 over 12 I can reduce to 5 over 6. So let's see, I'm going to have 5 pi over 6 times the sine of pi H over 12. And that gives our derivative function. So that's it for the first problem. Okay, next page. Now, I like these problems on page 2 because it's going to help us differentiate or distinguish between some different vocabulary and the processes we need to use. So let's take a look here. It says the temperature between 6 a.m. and 6 p.m. is given by our function T here. It's asking, what is the average temperature? So when I see average temperature, I have the function for temperature. So this is just asking for the average value of T on the interval. Well, at 6 a.m. is 0 and 6 p.m. is 12. So if I want average temperature, that's just my average value. So I know that the average temp is going to be equal to 1 over 12 minus 0, or 1/12, times the integral from 0 to 12 of T of T dt. And we're going to use our calculator for that. So I have 1 divided by 12 times the integral from 0 to 12. And let's see, our temperature function is 50 plus 25 times the sine of 0.26x minus 1.31 dx. So we get 53.965. And let's see, it doesn't give us units there, so we don't have to worry about that. So that's the average temperature. Now, I want us to be really careful when we see part B. Now they're asking us for the average rate of change in the temperature. When we see average rate of change, we should be thinking of slope. So notice, average temperature is very different from the average rate of change of the temperature. Okay, so now I want the slope. Well, I know 6 a.m. is time equals 0, and I know 6 p.m. is time equals 12. So if I want the average rate of change, what I'm finding is t of 12 minus t of 0 over 12 minus 0. So now I'm going to need to use my calculator to figure out these two values. So for t of 12, I'm just going to use my temperature function and my calculator to figure out that value. So I have 50 plus 25 times the sine of 0.26 times 12 minus 1.31. And I get 74.288. So I'm going to fill that in. And then minus, let's see here. We have 50 plus 25 times the sine of 0.26 times 0 is just going to be 0, so it's going to be a negative 1.31. Oh, what did I do here? Oh, I used my minus instead of my negative. Sorry about that. Okay, we get 25.845. And that's going to be divided by 12. So one last calculation here, 74.288 minus 25.845 divided by 12. And we get 4.037. Okay. So for our next one, now we're going to use the mean value theorem. Now remember, the mean value theorem that says if a function is continuous on a closed interval, the function is going to take on its average value at some point c over that interval. So let's see. Here it says at some time c between 6 a.m. and 6 p.m., so our interval from 0 to 12. The instantaneous rate of change of the temperature must equal the average rate of change of the temperature. Oh, sorry, this is our MVT for derivative. So I'm saying average rate of change is equal to the instantaneous rate of change. Okay, so why must this be true for the temperature function, and what is the value? Okay, so we knew the conditions were that the function had to be continuous on a closed interval. So we know since temperature is continuous, the mean value theorem applies. So now we need to find our value of c. So again, it says the instantaneous rate of change, so t prime of c, has to equal the average rate of change. So we know that's our t12 minus t of 0 over 12 minus 0. Right? And we knew that value is approximately 4.037. So I need to figure out where these things are equal. So first we need to find our derivative. Well, let's see. Our derivative here, if we look at our temperature function, again given to us up here, that 50, the derivative is going to be 0, so that's going to drop out. So I'm going to have 25. So let's see, t prime of c is going to be 25. Derivative of sine is going to be cosine. I'm going to keep my insides the same, times 0.26t minus 1.31. And I'm going to multiply by the derivative of my insides, which is going to be times 0.26. So if I simplify 25 times 0.26, I'm going to get 6.5 cosine of 0.26t minus 1.31. And again, I want to know where that's equal to 4.037. Now, I could type these in as two functions. This, my derivative, could be y1, this could be y2, and I could find the intersection. However, what I'm going to do is I'm just going to put it in my calculator as 6.5 times the cosine of 0.26t minus 1.31. I'm going to subtract that 4.037, and I'm going to find where that is equal to 0. That'll give me my values of t. And obviously, we're going to use our calculator to do that. So I'm going to go to my y equals, and I'm going to type all of this in. So 6.5 times the cosine of 0.26x minus 1.31. And then we're going to subtract 4.037. I'm going to graph it. I'll likely have to change my window here. So we know our window, we're looking from 0 to 12. All right, so I can see I have 2 intersection points. We're going to use our second trace there to calculate the 0. So over here, for my first 0 here, I want to be below for my left bound, so I'm going to make sure my y is negative. For my right bound, I want to make sure y is positive. I'm going to hit enter. So my first 0 is at t equals 1.574. So I'm going to put that here. And then my next one, now my right bound, or my left bound, excuse me, is going to be positive. So let's see when we get over here. I'm going to get a little closer. All right. So my y is still positive. I'm going to change my right bound till my y is negative, hit enter, and my second value is 8.503. And those are the values that are going to satisfy the mean value theorem. So that is where the average rate of change is equal to the instantaneous rate of change. All right, so now part D, this is where I was a little bit ahead of myself. Now we're going to do mean value theorem for integrals. This is when we know that the average value has to take on, or the function has to take on its average value. Okay. Now, again, we know that the mean value theorem applies, again, because temperature is a continuous function. So the MVT has to apply. So now we want to find out what value of C is the function value equal to its average value, right, which we got from part A. That average value was 53.965. So now again, I'm going to use my calculator. I'm going to use my temperature function. I'm going to subtract 53.965, and I want to find out where that is equal to 0. That'll give me the value of C where the function takes on its average value. So I'm going to go back to my y equals, clear this one out. Let's see, my temperature function was 50 plus 25 sine 0.26x minus 1.31, and we're going to subtract 53.965. We're going to look for a 0 in our interval from 0 to 12. And there we go. Okay, so again, second trace to calculate the 0. Left bound is negative, right bound is positive, and this happens at t equals 5.651. So at that point, the actual function value is equal to the average value of the function. So that's it for average value, and now you've got videos for the whole chapter. We'll be doing a little more practice with average value, and then we start review for the test.